This lesson is chapter 12.2, Negative Exponents and Scientific Notation. And I want to express to you that we have negative exponents. Now, the negative indicates that a to the n is going to have to take the form of a reciprocal of a to the n, which is going to be 1 over a. And since we did the reciprocal, then the negative will just become positive, so it's a to the n. For example, we have x to the negative 3 power. That negative requires us to get the reciprocal of x to the third, which is 1 over x to the third. And since we did the reciprocal, the negative sign will not be used. So if we do example A, simplify by writing each expression with a positive exponents. We have 3 to the power negative 2. So we're going to take the reciprocal, and it's going to be 1 over 3 squared. For number 2, we have 2 times x to the negative 3. So we're going to have to get the reciprocal of the variable only. So 2 remains in the numerator, and the x goes to the denominator, and it's x to the third. Number 4, the reciprocal of negative 2 will be 1 over negative 2 to the fourth. And for number 3, we're going to have 1 over 2 plus 1 over 4, because we got the reciprocal of 2, which is 1 over 2, and the reciprocal of 4 is 1 over 4. In this part of the lesson, we're going to have some examples. For example, number 5, we have parentheses 2 divided by x raised to the negative 3. That negative requires us to find the reciprocal of 2 over x, which is x over 2, and it's going to be raised to the third power. For number 6, as you see, we have a negative 2 in the denominator. We have an exponent of negative 2 in the denominator, so it's going to be y times the reciprocal, which is going to be y squared, this will be y to the third. Because remember, we have 1 over y to the negative 2, and the reciprocal 1 over y to the negative 2 power will be y to the second power, and it has to be positive since we got the reciprocal of 1 over y. For number 7, the reciprocal of p raised to the negative 4, we'll move it to the denominator, and q to the negative 9, we'll move it to the numerator. Example 8, we have x to the negative 5 power divided by x to the 7th power. So we already have a 1 in the numerator, and we have an x to the 7th in the denominator. So now x to the negative 5th power will go to the denominator. So you have x to the 5th. So you have 1 over, we have the same base, so it will be x to the 12th, which is the sum of 7 plus 5. You notice for number 9, we have x cubed raised to the 4th. Now we know if we have a power raised to a power, we're going to multiply. So we have x to the 12th power times x divided by x to the 7th. So we have x to the 13th divided by x to the 7th, which will be, since we have 13 How do we get 13? 12 plus 1 gives you 13 divided by x to the 13 divided by x to the 7th. So you have to subtract these exponents. So you have x to the 6th. For number 10, we have a negative 3 as an exponent. So we're going to go ahead and find the reciprocal of this expression. So we have b divided by 3a squared. And we're raising this to the third power. Therefore, we can separate this. We can say b to the third power divided by 3 to the third power. And we have a to the second raised to the third. So that's a to the 6th. Since it was a negative, we took the reciprocal of 3a squared divided by b. So we have b now in the numerator, and we have 3a squared in the denominator. And since we're raising it to a 3, and we know that that's a 1, and we know that's a 1, a power raised to a power, you're going to multiply. Number 11, we have y raised to the negative third power, and it's raised to the negative 6th power. And we have z raised to the 6th power raised to the negative 6th power. What I'm going to do is I'm going to go ahead and multiply these exponents. So we have y to the negative 18th. Positive 18th, because a negative times a negative is positive. And then we have z raised to the negative 36th power. So y to the 18th will be divided by z to the 36th. Since it was a negative, that will have to go to the denominator. Number 12, we have x raised to the negative 7th power divided by x fourth raised to the third power. So a power raised to the power, you're going to multiply. So that's x to the 12th. And since that's negative, x to the 7th is going to go to the denominator. So we have 1 divided by x to the 12th times x to the 7th. Number 13 to the 3rd raised to the 2nd power. And since we have a power raised to a power, we have 1 divided by 5 squared. And then we have 3 and 2. So that's 3 times 2. So it's y to the 6th power. The next section is we have the following number that we want to convert to a scientific notation. So we're going to go ahead and move the decimal place until we reach this point, which is between 3 and 6. We want to have a number here that's going to be between 1 and 10. So you notice we moved over 1, 2, 3, 4, 5, 6, 7, 8. So this will be 3.67. And I'm going to check again. 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the 8th power. Since we're moving to the left, it will be positive, and the exponent will positive will be to the power 8. If we move to the right, like we're going to do for the next number, we have 0.0000003. We have 6 zeros, so we're going to go ahead and move to the right. So we have 1, 2, 3, 4, 5, 6, 7. So we're going to have 3.0 times 10 to the negative 7. And we're going to go ahead and count that again. 1, 2, 3, 4, 5, 6, 7. You notice, for example, D, we have 420,000, and we're going to convert that into a scientific notation number. So we have 420,000, and we're moving to the left. So we have 1, 2, 3, 4, 5. So it's going to be 4.2 times 10 to the fifth. So if we move to the left, the exponent will be positive. If you move to the right, the exponent will be negative. So we have 0.000, and then we have 17. So we're going to move this decimal to the right. We have 1, 2, 3, 4. So this will be 1.7 times 10 to the negative fourth power. So we move right. The exponent is negative. If we move to the left, the exponent is positive. For example E, we're going to write the following in standard form without exponents. So we have 1.02, and you notice that that is a positive number, so we're going to go ahead and go to the right 5 spaces. So we have 1, 2, 3, 4, 5, and go ahead and just add your zeros. And so we have 1, 2, 3, comma, that's 102,000, okay? For example, in C, we have 8.4, and we have times 10 to the seventh, and the exponent is positive, so I'm going to move to the right. 1, 2, 3, 4, 5, 6, 7. And all you have to do in the space is just add the zeros. And then what you can do is you can count 3 spaces, comma, 3 spaces, comma. So we have 84 million, right? Example B, we have 10 to the negative 3 power. So we're going to go ahead and move to the decimal to the left side. So we have 7.358. So we're going to move over 3 spaces. So we have 1, 2, 3. So it will be 0.007358. And if you look at example E, we have 10 to the negative 5 power. So we're going to have 3.007, and we're going to move 5 spaces to the left. 1, 2, 3, 4, 5. So we have 1, 2, 3, 4. So it's 0.0003007. So if the exponent is positive, you're going to move to the right if you want to write it without exponents. And if the exponent is negative, you're going to move to the left. Example F, we're going to perform the following indicated operation. Then you notice we're multiplying. So we're just going to go ahead and multiply 8 times 7 times 10 to the negative 6 power times 10 to the third power. 8 times 7 is 56. So we have 56 times 10 to the negative 3 power. And so we're going to go ahead and move the decimal place 3 places. So it's 1, 2, 3. So it will be 0.056. For B, we're going to go ahead and divide 12 divided by 6, which is going to be 2 times 10. And we know that we have to subtract the exponents. So it's 2 minus a negative 3. So it's 2 times 10. That's positive. So that's going to be 5. So we have 2, and we're going to go 1, 2, 3, 4, 5. So it will be 200,000.